Kareem has 23 candies. He eats n candies and divides the remaining candies equally among his 3 children so that each child gets an integer number of candies. Which of the following is not a possible value of n? So he starts with 23 and he's going to eat n, and then what's left he divides by 3, and this number has got to be an integer. Got it? So let's just plug in values of n. So if n is 2, this number 23 minus n divided by 3, that will be, let's see here, 7. If it's 5, it will be 6. I'm going through the answer choices. If it's 9, it'll be 14 over 3. Okay, so there's our answer, but let's just complete it. If it's 11, it'll be 4, and if it's 14, it will be 3. So the only value of n that is not possible, meaning it won't give an integer number of candies, is 9. So number 11 is C. A 6 by 8 rectangular field has a fence around it. There is a post at each of the 4 corners of the field. Starting at each corner, there is a post every 2 meters along each side of the fence. How many posts are there? So let's draw 6 by 8 and let's go through this. So there's a post at the corners, so let's draw those in, and then every 2 meters. So this will be like at 2 meters, this will be at 4 meters, and then of course you got the corner one at 6 meters. Similarly, 2, 4, 6, like that. And then same thing on that side, 2, 4, 6, like that. Okay, let's count them. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Therefore, number 12, the answer is B. The integer 23 is equal to 7 times 17 squared. Which of the following is the smallest positive perfect square that is a multiple of 23? Okay, so what are they really asking here? They're saying something is going to be a perfect square. Which of the following is the smallest positive perfect square that is a multiple? So which one of these is a smallest? Okay, that's the key, because a lot of these, well, that's a perfect square, but we want the smallest one. Okay, so to make this a perfect square, all I would have to do is multiply both sides by 7. And if I do, this becomes 7 squared times 17 squared, which is the same as 7 times 17 all squared. And as you can see, that's a perfect square. And therefore, this side is the smallest way I can do that. There's many other ways, of course, infinite probably. So 7 times 23 is the answer for number 13. Points A, B, C, D are on a line in that order. Distance from A to D is 24. Distance from B to D is 3 times the distance from A to B. Point C is halfway between B and D. What is the distance from A to C? All right, let's do this here. So we got A, B, C, and D. Okay, let's go through this. Distance from A to D. Well, I'm going to have to label this. X, Y, and Z like that. A to D is 24, so that basically means that X plus Y plus Z is 24. Distance from B to D, which is Y plus Z, is 3 times the distance from A to B, which would be the equivalent of saying 3x. And then C is halfway between B and D. Okay, so that means Y is equal to Z. That's the interpretation of that sentence. All right, so now we have to figure out A to C, which is saying find X plus Y. Yeah. Okay, so we got to figure out this. Let's concentrate on that equation there. X plus Y plus Z. Okay. Let's see here. What should I do? Okay, so X and the Y plus Z, this part is equal to 3x. So I'm just going to put that there. That'll give me just one variable, and then I can solve for it, which would be X equals 6. Okay, that's pretty good. And then where do I go next here? Oh, okay, I know. This equation here, Y plus Z is 3x, right? Well, X we just figured out was 6, so 3 times 6. So Y plus Z is 18. And since y equals z, I can put z equal to y like that. And then that means 2y is 18, and therefore y is equal to 9. And there we go, we got it. So x plus y, x is 6, y is 9, and therefore x plus y is 15. Therefore, number 14, the answer is E. Suppose that a is equal to 1 over n, where n is a positive integer with n greater than 1. Which of the following statements is true? Okay, as always in these kinds of questions, I just use a number. So if n is a positive integer greater than 1, you can use anything you want. I'll just use 3. So therefore, a, which is 1 over n, is equal to 1 over 3. And then they want us to compare a, 1 over a, and a squared. So let's see what these are. A is 1 over 3. 1 over a would be 3, and a squared looks like 1 over 9. Now I have to put these sort of in an inequality. Well, 3 is the largest, and then 1 over 3, and then the smallest is 1 over 9. So this would be sort of the inequality, and that means the 3 was the 1 over a, right? And then the 1 over 3 was a, and the 1 over 9, that's a 9, is a squared. So that's the inequality. And which of these answer choices is that? This is an A. I'm sorry. I know sometimes my A's are looking like 9s and 9s are looking like A's. So anyhow, back to the question, which one of those inequalities, I believe it's this one here, is a squared is less than a, which is less than 1 over a. Yeah, so 15, the answer is B. In the diagram, ABCF is a rectangle with AB equal to 30 centimeters and AF is 14. Points E and D are on FC so that FE is 5. Area of the quadrilateral ABDE is 266. The length of DC is. So let's put this in. 266 goes there. And 30 and 14, I think that's all. Oh no, FE is 5. All right, let's see what we get. First, let's figure out the area of this little triangle in here. That guy. It's basically 1/2 base times height. Base is 5, height is 14. So I believe that looks like 35 to me. So put 35 in here. 35. And then the entire rectangle, that is going to be 30 times 14 in terms of its area. And 30 times 14 is 420. So to figure out this guy, I would have to take the 420 and subtract from it that 266 and that 35. And when I do, I think I get 119. Yeah. So then what are they asking for? DC. Okay, I got it. So that's 14. So 119 would therefore be 1/2 base times height, which is DC times 14. So that's 119 is equal to 7 times DC. And then therefore DC is 119 over 7, and that's 17. So DC is 17, and therefore number 16, the answer is A. Megan and Hannah raced their remote control cars for 100 meters. The two cars started at the same time. The average speed of Megan's car was 5 over 4. Hannah's car finished 5 seconds before Megan's car. What was the average speed of Hannah's car? Okay, so distance is 100 meters. The speed of Megan is 5 over 4. And the time of Hannah, I don't know, I'll just call it X, but the time of Megan is 5 seconds fast, or 5 seconds before, so it'll be X minus 5, I believe. Yes. Okay, so speed is equal to distance over time, and therefore this speed right here, which is 5 over 4, would be the equivalent of Megan's distance, which is 100, divided by her time, which is X minus 5, right? Actually, hold on. Who are we figuring this out for? Megan. And Megan, I think I reversed this. Hannah's car finished 5 seconds before Megan's car. So Megan should be x and Hannah should be x minus 5. Sorry about that. Okay, so we'll put x there. Okay, there you go. Okay, now we can solve for x pretty easily. Cross multiply 5x is 400, and therefore x is 80. All right, so this x is equal to 80, and therefore this x minus 5 is 75. And now what do they want? The average speed of Hannah's car. Okay, so speed is equal to distance over time. Distance is 100. Time we just figured out for Hannah is 75. And this in lowest terms, I believe, would be 4 over 3. And therefore, number 17, the answer is C. A factory makes chocolate bars. 5 boxes labeled V, W, X, Y, Z are each packed with 20 bars. Each of the bars in the 3 of the boxes has a mass of 100. And each of the bars in the other 2 boxes has a mass of 90. Okay. 1 bar is taken from box V, 2 are taken from W, 4 are taken from X, 8 from Y, and 16 from Z. Total mass of these bars is 2920. The boxes containing the 90-gram bars are labeled. All right. Interesting question here. V, W, X, Y, Z, and all of them have 20 bars. Okay, so that's the only thing that we know for sure. But then they're saying that each of the bars in 3 of the boxes has a mass. Okay, so we're not told which of those. I got it. So I don't know which box has bars that are 100 grams and which box has bars that are 90. Okay, I got it. And then, but we are told that we're taking 1 from here, 2 from here, 4 from here, 8 from here, and 16 from here. Okay, so we got to do a little bit of a guessing game here. Okay, so let's assign. How do I do this here? Okay, let's just assign. Let's say that these first 3 were the 100-gram bars, and the last 2 are the 90-gram bars, and let's see what happens. So 2920 is the sum, and we are going to take 1 bar from the V, and that's going to be 100. 2 bars from the W times 100 each, plus 3 bars from the X. Oh, sorry, not 3, 4 times 100. And then we're going to take 8 from Y, and each bar is 90. Well, at least each bar is 90 is what I'm assuming. I don't know that for a fact. I'm just doing some trial and error here. Okay, so that's the equation, right? Now let's see. When you do this math, you get 2860. So 2860 is not equal to 2920. So this is obviously incorrect, but no problem. That helps me in a way, because I know in order to get from 2860 to 2920, I have to increase by 60, right? So I'm going to make some adjustment here. And that's what I have to think. Well, how do I increase by 60? Let me think about this. If these 2 went down to 90, that would mean minus 20. Yeah. Minus 20. And then if these went up to 100, that'd be adding 80. So 80 minus 20 is 60. That's it. Okay, so let me explain what I did. So this stays the same here. But what I did was I'm going to make this the 91. So that becomes 2 times 90. This stays the same, so that's 4 times 100. And then this guy, I'm going to make 100, I believe, yeah. So that becomes 8 times 100. And this stays the same at 90. And so it's 100 times 2 times 90 plus 4 times 100 and 8 times 100 and 16 times 90. So it's 100 plus 180 plus 400 plus 800, and 16 times 90 is 1440. And this equals 2920. Okay, So what that means is that they ask which boxes contain the 90-gram bars. Well, according to my calculations, it was W and Z. So number 18, W and Z, I believe, is B. The average of A, B, and C is 16. The average of C, D, and E is 26. The average of A, B, C, D, and E is 20. The value of C. Okay, so A plus B plus C, the average of those three numbers is 16. And then the average of C plus D plus E is 26. And then finally, the average of A plus B plus C plus D plus E is 20. Okay. All right. So the first one, A plus B plus C, is therefore 48 when you cross multiply. The next one, C plus D plus E, is 78. And then the last one, A plus B plus C plus D plus E, is 100. And what are they asking for? The value of C. Okay, somehow we got to figure out C. All right. Okay, so from this guy, A plus B plus C is 48. So that's plus D plus E is 100. So D plus E is therefore 52. And then I guess we just put it in here. C plus D plus E, which is 52, is 78. So therefore C would be 26. Am I right? I think so. So number 19, the answer is D. A robotic grasshopper jumps 1 centimeter to the east, 2 to the north, 3 to the west, 4 to the south. After every fourth jump, the grasshopper restarts the sequence of jumps: 1 to the east, 2 to the north, 3 to the west, 4 to the south. After a total of n jumps, the position of the grasshopper is 162 to the west and 158 to the south of its original position. The sum of the squares of the digits of n is... Okay, dokie. All right, we're going to have to visualize this. So let's say this is my original position. So where are we going? 1, then 2 up, then 3, and then 4 down. Correct? Yeah. Okay, so we're going to have to make a little bit of a tally here, and hopefully we'll get some sort of pattern, and I hope that pattern will help you understand how we can get eventually to 162 and 158. Okay, so this is N, this is west, and this is south. Okay, so let's talk about this. And this is our first move from here. This is our original position here. So after our first move, we are there. Now we're not west or we're not south, so I'm just going to leave a blank there. For the second one, again, we're not west or south. We're still not even in those directions, but at that point we are west. And how much are we west? We are 2 west, but we're still not south. Now the fourth move ends up here, and we are 2 to the west and we're 2 to the south, I believe. Okay, got it? So I'm not trying to make this confusing, just slowly starting to kind of piece this together. My hope is that the pattern will come pretty quickly because we don't want to go on forever. Okay, so now let's keep this going. I gotta make sure I draw this to scale here. 1 going east, then 2 going up, and then 3 going west, and then finally 4 going down, right? Okay, so now compared to the original position, where are we? For the fifth guy, it looks like we are 1 and 2. For the sixth move, which is there, we are 1 and 0. Yeah. And then at the seventh move, we would be 4, I believe. Yeah, 4 and still 0. And then at the eighth, which is here, it would be 4 and 4, right? Yeah, 4 and 4. Yeah. Okay, that's pretty decent. And yeah, that's what I'm trying to do here. So far so good. Okay, let's keep going again. So 1, 2, 3, and 4, like that. Okay, now let's see here. 9, 10, 11, and 12. So this is 9, 10, 11, and 12. And by now I think you kind of understand what I'm doing, so I'll just fill them in. 3 and 4, 3 and 2, 6 and 2, and 6 and 6. And then I'm just going to go through this one more time. And let me do this carefully here. 1, 2, 3, and 4. So this is my 13, this is my 14, this is my 15, and this is my 16. So 13, 14, 15, and 16. So let's see here. 5 and 6, 5 and 4. For 15, it would be 8 and 4. And 16, 8 and 8. Okay, I think at that point, you guys get the idea of the pattern. Now, we got to eventually get to 162 and 158. Okay, so we got to get to 162. So dot, dot, dot. Eventually, we have to get to where this is 162 and this is 158. Right? So let's just put this 4 and 8 over there. Okay, so how do we do that? And what value of n is that? Okay, well, and initially it's not entirely clear, but I can guarantee you that I can figure out when it's 162 and 162. Because you see, for 4, it was 2, 2. For 8, it was 4, 4. For 12, it was 6, 6. For 16, it was 8, 8. So it looks like you're just halving the numbers, cutting them in half. So for 162, the double of that is 324. So 324 is the value for n. I'm pretty sure about that. Now we want to work backward. Well, if you go backward, you notice that one move before, the value for w doesn't change, but the value for s goes down by 4. You see what I mean? Happened here, and I mean, this one isn't, this one is meaningless, but you can see from the other ones it goes down by 4. So I'm pretty confident that this guy is 323. And that is the value for n that we want. But they want an interesting thing. They want the sum of the squares of the digits. Okay, so the digits are 3, 2, 3, and they want the sum of the squares. Okay, we can do that. So that's 9 plus 4 plus 9. And I believe that is 22. So, answer to number 20 is A.